Before we can work with RESTconf, we need to understand Yang better. We'll use the PyYang tool from previous courses to explore the IETF routing models first. Hopefully you remember the PyYang package from a previous course. I've already installed it to save a little time. We can feed Yang models into PyYang to get a human-readable tree representation in response. RFC 8340 describes the tree format in detail for those who want to read the formal spec. Using PyYang from the shell can be burdensome, so I've written a bash script named maketrees.sh to simplify the process. We run PyYang twice here, effectively exploring two separate Yang models. In both cases, we specify the tree format and the PyYang search path. The reason I'm using a very specific search path is because the IETF models, despite being standards-based, are a little different across platforms. I want to ensure I grab the right ones. We then specify the output file for each PyYang run, writing a text file into the dataref directory. Finally, we specify the Yang model to convert. Since the demo is based on static routing, we will explore the general routing model followed by the IPv4 unicast specific model. As a quick note, you can clone this repository to collect the latest Yang models from many vendors and platforms. Let's quickly run the script to generate our PyYang trees. Let's ensure PyYang generated our files correctly. Okay, I see two text files. We can begin with the IETF routing model. The module is named IETF routing, and all the items we currently see are read-only. These are contained under the routing state container, which isn't important to us right now. These aren't configurable items, so let's jump to the read-write section. The topmost container is named routing, and this contains a list named routing instance. Each item in the list has a variety of attributes such as name, type, enabled state, etc. The name attribute is the key, meaning that we must specify the routing instance name to access an individual item. In our case, we are using the default routing instance, meaning the global routing table. Within each routing instance, there is a routing protocols container that contains a routing protocol list. Different routing protocols such as BGP, OSPF, and static could be included here. What makes this list interesting is that it requires a two-tuple as its key. We must specify both the type and instance name to access an item. Oftentimes the name can be a number, like an autonomous system number, and for static routing, we use the number 1. We'll confirm that when we see the sample JSON output from the device. For example, this allows you to configure multiple OSPF processes in the same routing instance on a given device. What is this static routes attribute? This gets expanded in the other Yang model, which is specific to IPv4 routing. It contains more details about the structure of an individual static route. Let's open the IETF v4ur file to check it out. This short file reveals the attributes a static route will have. The module augments the IETF routing model we just looked at. Within the IPv4 container, there is a route list that uses destination prefix as the key. The destination prefix is a custom type that uses / notation to include a network and prefix length. Here's a screenshot from the Yang type definition that explains it. We won't scrub this regular expression, but in general, an IPv4 address contains 4 octets in dotted decimal notation. To make it a prefix, the regex matches a / followed by more digits representing the prefix length. This should look familiar to network engineers. Then, there is a next hop container with some different next hop types. We'll use the next hop address in our demos, which means specifying a dotted decimal IPv4 address. The outgoing interface option is represented by a simple string, but the next hop address consumes another custom type. Once again, here's a screenshot directly from the Yang model. It's similar to the IPv4 prefix, except doesn't match the / notation to signify the prefix length. Now that we have a basic idea of how static routes should be structured on iOS XE, let's leverage the DevNet Sandbox for testing. In the next clip, we'll collect the currently configured static routes using the Python requests library.